Accessible iOS Apps in Practice, presented by Ashton Williams, AliCamp 2021. We'd like to thank our gold sponsors Telstra and Intopia, our silver sponsors ANZ and Coles, and our bronze sponsor How2.
Today, in Accessible iOS Apps in Practice, I will be talking about native iOS app accessibility. Let's learn about some of the assistive technologies available to users on iOS and the code you need in your app to support those technologies. Then we'll explore some user interface components that Apple provide from an accessibility perspective and compare that to custom components we might be building to better suit our needs and branding. There will be some code examples. I'll do my best to explain it, but don't worry about understanding exactly what it is doing. I should introduce myself first. My name is Ashton Williams. I recently joined the team at Seek. I'm still new, but I'd love to hear your feedback on the Seek app. Before that, I was at National Australia Bank as the iOS tech lead. We did a lot of accessibility work there, and I'm sure they would still love to hear your feedback too. I'm also on Twitter at AshtonDev if you'd like to get in touch with me. Let's begin. First, let's cover the user-facing iOS accessibility technology, what Apple often refer to as assistive technology. First, there's dynamic type, also known as larger text. This is a system-wide, or per app in iOS 15, setting to adjust the size of text and some other elements. You can also make the text smaller than default if you want more content on your screen. It's a great feature for everyone. Next is VoiceOver. This is Apple's screen reader. On iOS, it also includes a gesture-based focus system and rotors. Voice control. It's an on-screen overlay that identifies user interface elements with either numbers or names, and it lets users talk to their device to interact with those on-screen elements. Switch control, which is a focus-based navigation system controlled by on-device or external hardware switches. Full keyboard access, which allows you to navigate with an external keyboard. There are a lot of preferences too, like bold text, button shapes, increased contrast, reduce motion. You can use many of these technologies together, like VoiceOver and voice control at the same time. But an app developer doesn't work with technology like VoiceOver directly. Instead, we build our app using generic accessibility application programming interfaces, or APIs for short. This allows the same code to enable all of the technologies we just mentioned, not just one at a time. So you don't program your app to work with VoiceOver specifically. You program it according to Apple's guidelines and APIs, and that makes your app work well with VoiceOver, voice control, switch control, braille displays, and lots more. This is a small selection of the code components you use most often when making adjustments for accessibility with apps built with UIKit. UIKit is the framework used to build iOS apps. In 2019, Apple released a new multi-platform framework called SwiftUI, which does UI very differently, and accessibility is done differently too, but it is similar. A bit more on that later. Most of these are properties on a view, which is just any on-screen visual element. First is accessibility element. You set this to true to make a view known to assistive technology. This makes it focusable. You set it to false to hide an element from assistive technology. Labels and controls have this enabled by default. Accessibility label. This describes and identifies the element. It usually matches any visible text. Accessibility value is the current value of the element most commonly on controls, like the text in a text field or the percent on a slider. Accessibility traits, a set of options to describe the behavior or characteristics of an element, like being a button or a header, or being selected or disabled. These are mostly included in the reading or display of the accessibility label and value, but sometimes they just instruct behavior. These are preset and the options are limited. Accessibility hint. This is text that describes the result of interacting with this element or any other relevant hint. For example, double tap to edit, or use the rotor to access misspelled words. The user can turn off hints. Perhaps once they are comfortable using your app, they'll just turn them off. The last one is not a property on Vue. Instead, this is a function you can call from anywhere. It's UIAccessibility.postNotification argument. This sends a message to the assistive technology, for example, to request it to announce some text, or to request it to select a new element. I'm not going to be covering dynamic type, increased contrast, reduced motion, or other visual accessibility concerns. These are important, and you should definitely be thinking of them in your design phase and when you're building the UI code. But I want to focus on just these ones. Here I have a standard label and a text field. It kind of looks like a text field. These are what they look like by default. There are two elements here. VoiceOver reads the label as name and the text field as text field. Double tap to edit. The last part is a default hint. In forms, it is common to associate labels with their form field. By default, views containing text are accessibility elements and will be focused and read. We can turn this off if we want to make it easier to navigate a form by going straight into the fields. You would do that by setting the isAccessibilityElement property to false. Here I've done that on the name label. Now assistive technology will ignore the label. This has created a new problem though. Because the label and the field aren't actually associated with each other, now the only thing telling us this field is for the name has been hidden to accessibility. VoiceOver now only has one element, the text field, but it reads this as text field. Double tap to edit. We can fix this though by setting the accessibility label of the text field with the code namefield.accessibilitylabel equals name. You can also notice in this example that I did not have to set isAccessibilityElement to true on the text field. I didn't have to set the accessibility label of the label, and I also didn't have to write the hint. Apple have really good defaults to make things mostly accessible already. Accessibility value is normally used by editable controls. The text in a text field is automatically the accessibility value. Simpler controls like buttons and switches will announce their accessibility value if it changes when the user activates it. You are free to use it in non-interactive elements too. For example, here I have a view that contains two labels. One is distance, and the other is the number in kilometers from your destination. In this example, it is 60 kilometers right now. I've chosen to have this be a single accessibility element, and I use the accessibility value to contain the distance from the destination. To do that, on my distance view, I have set isAccessibilityElement to true. I have set the accessibility label to distance, and I've set the accessibility value to 60 km. VoiceOver reads this as distance 60 kilometers. Note that VoiceOver correctly understood km to mean kilometers. If VoiceOver didn't do this, I might change my accessibility value to not use the abbreviation, even though my on-screen label does. In a more realistic example, the distance to your destination wouldn't stay the same. It changes as you move. So actually the accessibility value needs to be calculated and updated by some code function. There is also a behavioral trait for an element that updates frequently. Let's use that as well. On my distance view, I now set the accessibility traits to include the updates frequently trait. Views have multiple traits, so you should usually add and remove traits individually instead of replacing the existing ones. This is done by setting accessibility traits.insert updates frequently. I've also added a function to be called by my code that tracks the distance to your destination. In here, I've written distance amount label.text equals distance km. And then distance view.accessibility value equals distance amount label.text. So it'll be the same as the value shown on screen. Now VoiceOver reads this element as distance, 60 kilometers. But a couple seconds later, it will read the value again as 61 kilometers, and then 62 kilometers, and so on. Other useful traits are button and heading, which mark your views as a button and a heading. They are then included in the VoiceOver readout and also used for navigation purposes. Let's add an accessibility hint to this distance view too, since its behavior is a little bit uncommon. Distance view.accessibility hint equals changes in real time. Keep focused for updates. Lastly, UI accessibility.post notification argument. When we approach our destination, we might visually grab the user's attention with some graphical display or text appearing on screen. For assistive technology, we can send an announcement too. This will be read by VoiceOver, no matter what element is currently focused. We do this with UI accessibility.post notification.announcement argument nearing destination, distance 1 kilometer. We can also use these notifications to do things like move focus to a particular element or give feedback to assistive technology about the user's current scroll position. For example, page 1 of 2. Briefly, let's also talk about SwiftUI again, Apple's new declarative UI framework. Instead of setting properties on views, you now add modifiers in your view description, but it looks pretty familiar. There's accessibility label, accessibility value, accessibility traits, accessibility hint, and some new tools like accessibility element children, which allows you to do things like combine multiple views together into a single accessibility element automatically. Apple have a great set of SwiftUI accessibility videos at their developer.apple.com website that you should check out if you're interested. So now we know how to make things accessible. Great. Let's follow the story of a control. This is an example of a standard control and then our task to make a custom version. Let's look at the UI switch. It's a pretty good component. It's announced as switch button off, double tap to toggle setting by VoiceOver. Out of the box, it already supports VoiceOver, switch control, voice control, increase contrast, on-off indicators. It's pretty accessible. Here's my checkbox. It's a subclass of UI control. That's one of the ways it can be implemented. I've made it so that it visually looks like a checkbox, and it's already functioning as a checkbox when I tap it without using any assistive technology. But it's completely hidden to accessibility. Do I just need to enable isAccessibilityElement? That makes it focus with VoiceOver, but VoiceOver doesn't read anything. It's empty. I can double tap to activate, and it does check the box, but VoiceOver again reads nothing. This is far worse than what the UI Switch gave us for free. Sorry for the amount of code here. I've trimmed off some of the unimportant UI bits. I'll take you through this now. This control is composed of an image view. If it contained any other views that had default accessibility, like a label, then those elements would be focusable, but this control should be a single element. Starting from the bottom, when a touch event begins tracking, we toggle the isChecked state of our control. Assistive technology will simulate a touch. If you want to handle just assistive technology events, there are functions like Accessibility Activate that you can override instead. When isChecked is set, the didSet code is called, and that calls update control, which just swaps the image back and forth between the checked and the unchecked. So this isn't too complicated, but it's not accessible. Here, I've fixed some of this accessibility. It now works with VoiceOver, Switch Control, and Voice Control. I've added a Setup Accessibility function near the top, where I now set isAccessibilityElement to true. I give it an accessibility hint of double tap to toggle setting, just like the Switch had, and I set the accessibility traits to just dot button. Also, when we switch the image in Update Control, I now change the accessibility value to either checked or unchecked. Now this control is getting there. VoiceOver will read it as unchecked button, double tap to toggle setting. If you give it a label, it will read that too, of course. But that needs to be done when you actually place it in a designed screen. We only had to add 8 new lines of code so far, but this is a very simple control. Imagine something much more complicated, like an interactive graph, or a custom slider, or a date picker. Adding the accessibility afterwards can be difficult, and you might have written the code completely differently if you had planned ahead. I'm not saying you shouldn't make your app unique. You should represent your brand and you should have your own sort of style in your app. But do be aware of the accessibility you might be losing or the extra work you need to do to get that accessibility back when you're making custom controls. Also be aware of third-party custom controls you get open source or purchase. Make sure those are accessible too. Otherwise, the Apple controls are free. Don't go overboard on custom stuff. It's really hard and expensive to maintain and hard to make accessible. Here are some tips for success. Build things accessible as you go. Don't do accessibility last. It's much easier to integrate into your daily processes and avoid a big list of bugs. If you're watching this, you probably know this already, but we really need to get all developers on this, not just specialists. If you are building custom components, build an accessible component library or design system. Just like how working with plain UIKit components makes accessibility easier, even if you don't realize it's there, so does working with custom accessible components. Accessibility is everyone's job, so it should be in every step of your process. Thanks for giving me your time. I tried my best to communicate clearly and inclusively. If anything was not right, or you just have questions, you can reach me privately on Twitter @AshtonDev or through the AliCamp organizers. Thank you.
AliCamp 2021